we begin working with congruent figures, we need to understand or remember a few of our definitions. And thinking about congruent figures, we're talking about figures that are the same. So we want to be able to write congruency statements for the transformed figures. If they're the same, we want to be thinking about rigid transformations and remembering that our rigid transformations are reflections, rotations, and translations. And we want to be able to use those definitions to determine if the figures are congruent, and if so, identify their corresponding parts. And what we'll find here is that the corresponding CPCFC, and that is corresponding parts of congruent figures, are congruent. And then, of course, that allows you to help determine those unknown measures of congruent figures. So let's see here. Remembering that a reflection, it's a transformation relative to a given line of reflection. So you have the point on a pre-image, and the corresponding point on the image can be connected by a segment that is a bisector. So if we think about that, we have a reflection where we have a object or figure has been reflected over a line, and then that line forms a bisector, a perpendicular bisector, so the points of your image and pre-image. So when we look at this, that would mean the image from, I know this isn't a perfect drawing, but from C to C, so right here we would have a perpendicular bisector, and if that was point D, CD would be congruent to segment D prime. So understanding that the perpendicular bisector is cutting it in half. And then the same thing here, when we go from B, it would be a perpendicular bisector, and if that intersected at point E, well, BE and EB primed would be congruent, so BE would be congruent the same distance as EB primed. So that's what our reflection is. It's reflecting the object over a point, much like a mirror image, the reflection, right? And as we go to a rotation, rotation may be, and I use the coordinate plane for the rotations just because it's easier to see. So if we're starting off with, in this case, triangle ABC, we are going to rotate it. It looks like my A prime, my B prime, my C prime, my first is going to be a rotation which would be 90 degrees. Or a double prime, B double prime, C double prime, or my second rotation turns out that it was a 180 degree rotation, or a 90 degree rotation from my first transformation. So that rotation transformation, which each point of a figure is turned through a given angle or direction around a given point, called the center of rotation. And in this case, my center of rotation would have been my origin, because ideally all points of B, B prime, and B double prime are going to be the same distance, and then from the pre-image to the image. So that is a review of my rotations. Don't want to go there yet. So as I work with translations, my translation is a rigid move, and we're moving every point of the pre-image to an object of the same distance and direction to create this new image. So if I started off with a pre-image ABCD and I transformed it translated it 4-2, that's telling me that my x coordinates are going to change by 4, positive 4, and my y coordinates are going to change by a positive 2. So as I make that transformation, A is going to move right 1, 2, 3, 4, and up 2. So there is my translated A, and I'm going to continue to do the same with each point. 1, 2, 3, 4, up 2, which would be my B. C, it'd be 1, 2, 3, 4, up 2, so here's my new C prime, and then D prime is going to end up right there. So my new object, my new image, has been translated 4, 2, so there is my new image. So remembering what my rigid transformations are. So I can look at these, and I should be able to say, hey, it looks like AC is going to be congruent to A prime C prime because it's the same rigid, all the pieces remain the same, my angles in my segments, so that is congruent to that, and that is leading to that congruent parts of congruent figures. Corresponding parts of congruent figures are congruent because A, C, and A prime, C prime are corresponding to one another. And then, so here we have an example where we have two figures are congruent and their corresponding parts are going to be congruent. And let's look at this. And this image is showing us that triangle XYZ was reflected to form triangle LMN. So if we need to see that reflection, it would be along, they reflected it over an imaginary line, call that line L. So in the reflection, I should be able to see, well, even looking at the way they have written the triangle identification, XYZ is reflected to triangle LMN. So if I look at it, let's look at, knowing what we know, that right here, this would be angle Y. Angle Y is 86 degrees. And correspondingly, what is angle M? Well, angle M is also 86 degrees. So just in the order that you write the identification is going to identify some of the corresponding natures of the object. So I should be able to look at this and say, well, segment XY should be corresponding to segment LM. So if I look, segment XY is right here, and segment XY is running between my angles 86 and 38, and the corresponding segment would be segment LM, which is running in between segment 86 and some unidentified segment. Well, I can take a random guess here and say that, guess what, this is going to be 38 degrees because these two should be congruent. I can check that. I can check that by using my triangle information, so I know that a triangle is 180 degrees. Well, if I add these two together, 56 and 86 is going to be, 142. So that would be minus 142 degrees is going to be behind 38 degrees. So yeah, so this is 38 degrees. Angle L is 38 degrees. Or angle NLM, sorry. So I was able to fill that in. Well, correspondingly then I should also know that right here 56 degrees is going to correspond over here to 56 degrees. So I'm able to identify some of these corresponding parts, and again, so segment WZ is corresponding to segment MN, and then that means segment ZX corresponds to segment LN. So I'm able to use all this corresponding information, and again, so if I look at segment, or that angle is corresponding to this angle, and then this angle is corresponding to this angle. So I'm able to use those corresponding features when identifying corresponding parts are congruent, right? So if I have two figures that are congruent, these two appear to be congruent, then their corresponding parts are going to be congruent. Okay, so looking at this next example here, we're given that triangle GHJ is congruent to triangle STU. Okay, so GHJ is congruent to STU. So we can do some, finding some unknown measures of these corresponding parts. Well, this little hash mark tells me that this segment, GH, is going to be congruent to JG, which is also going to be congruent to ST, and it is going to be congruent to SU. So I know that GH is congruent to GJ, which is congruent to ST, which is congruent to SU, and that means they equal 5 centimeters. So I can label that. I got 5 centimeters. I got 5 centimeters here. I got 5 centimeters here on this segment, and then I know that. Let's see here. If angle, it looks like angle GHJ, it then corresponds right here, this angle, is going to correspond to angle STU. So if they're corresponding angles and they're corresponding angles of congruent figures, right? So that tells me then that we should also have over here, this should be 67 degrees. We can do some more information here. I can tell you that it looks like segment TU is going to be congruent to segment HJ. Therefore, HJ is going to be 3.7 centimeters. And what else do we know? Could we know something about angle T right here? Well, this is an isosceles triangle, right? It's an isosceles triangle, so my legs are the same, so that means my base angles are going to be the same. So I happen to know here that this angle and this angle are going to be congruent, therefore this angle and this angle are congruent. So we're looking at, this is going to be 67 degrees and this is going to be 67 degrees. And that does leave us with one measurement that we don't know on here, and that is going to be this last angle. And what we can do there is, hopefully you guys know that we take and we have 180 degrees minus our two base angles. So we're looking at 180 degrees minus 2 times 67 degrees. So that's going to be 180 degrees minus 134 degrees, which gives me, it looks like angle G is going to be equal to 46 degrees. Okay, so angle G is going to be 46 degrees. Then we know that angle G is going to be congruent to angle S, and they're going to equal not 56 degrees, but 46 degrees. So we're able to move around and identify corresponding parts of congruent figures and find out what that information is. All right, so one last example here. So we have two quadrilaterals. Quadrilaterals WXYZ and BADC are congruent. And it says, in addition, WX is congruent to DC and XY is congruent to BC. So if I were to draw some images here, just to make it easy on me, it's hard to visualize some of this stuff when it's written. So I have W, X, Y, Z, and I have B, A, D, C. And it tells me that they're congruent. So my corresponding sides, I've written it and made sure that my corresponding sides are, WX is corresponding to BA. And then DC, WX and DC are going to be congruent, and then XY and BC are going to be congruent. Okay, so that something like this. All right, and then it tells me that AD is going to be 4 centimeters. Okay, if AD is 4, then XY is 4. And then if AB is 6 centimeters, then WX is 6 centimeters. And then therefore we are looking at the perimeter. So what is my perimeter? My perimeter is going to be, some people have problems with perimeter still. What is that? That's adding up the outer edges. So I'm going to have 4, 6, 4, 6. So my perimeter is going to be equal to 20. And that is 20 centimeters. So as we look at this, congruent figures, remembering our transformations, corresponding parts of congruent figures are going to be congruent, and then we are looking at two figures that are congruent if and only if one can be mapped onto the other by one or more rigid transformations. So using those rigid transformations and just reflecting back on what we've already learned allows us to find out a lot of pertinent information as we move forward in geometry.